Let's take a look at rational or fractional exponents. This is a brand new topic for most of you here, and I basically have the definition laid out for you. Now when you look at it in this form, it may be a little bit confusing, but let me make some sense out of it for you. I've used the letters P and R to represent power and root, and anytime you have a fractional exponent, it means that you're dealing with a root. Now, this fractional exponent can either be said to be the rth root of x to the p, or the rth root of x raised again to the p. Now you look at that and you go, okay, what does that mean? Well, basically, this first one says that you can raise the value of x to a power, so I'll say raise first, then you can take the value you have and then root it. Or the second one says that you can root first and then you can raise it to a power. Now, you have an equal sign between these two, which says you're going to get the same result either way. So now let's actually put this into action and start seeing what this means. When we have 27 to the 4/3 power, we can either write this as the cube root of 27 to the 4th, or we can write that as the cube root of 27 all getting raised to the 4th. Now I consider that it's a lot easier to take the root first because we can get 3, which then gets raised to the 4th, which is equal to 81. Over here on the left, 27 to the 4th power, that's huge, and we would never be able to cube root that huge number in our heads without using a calculator. Now let's go back to the original understanding what an exponent is. An exponent tells you how many times a base is multiplied by itself. Now you can't take 27 and multiply it by itself 4/3 or 1 1/3 times. So you've kind of got to get rid of that way of looking at exponents and now look at it in a totally different way. I tend to always like to take the root first to make the number more small and manageable and then raise to a power. This problem asks us to take 4 and raise it to the 5/2 power. Now again, remember the 5 stands for the power and the 2 stands for the root. And since the root is 2, that means we're dealing with a square root. I think it's a lot easier that we take the square root of 4 first and then take that and raise it to the 5th power. This gives us 2 to the 5th power, which is equal to 32. Now if you look at the next few problems, they all appear to be very similar to each other, except that the negative is written in a different place. In this first one, we don't have a negative. I'm going to start by saying I've got the 4th root of 81, which I'm going to then cube. That becomes 3 cubed, which is equal to 27. In the second problem, the negative is out front, and so we don't have an issue at all. That just becomes negative 27. However, in this third case, because there's parentheses, we've got a little bit of a problem here because we have the 4th root of negative 81 then getting cubed, and we cannot have a negative inside of a 4th root, and so this has no solution, or let's just say cannot be simplified. Because we don't have any methods to work with yet for that. When the exponent is negative, you know that means we are going to have a fraction here. So this is going to become 1 over 81 to the 3/4, and as we've learned, this will become 1 over. This next problem relies on the one before it. Let me remind you that this is really a negative 1 times 81 to the negative 3/4. That negative exponent only applies to the 81, not the negative out front, because there's no parentheses. And so relying on the problem before this becomes negative 1 over 3. Because there's a negative inside the parentheses for this next problem, that would tell us we're taking the 4th root of a negative, and this one can also not be simplified. So cannot be simplified, at least using our current understanding level, or our current, at least using what we know now. This next set of direction wants us to be able to convert from rational exponents into radical form. And so on number 4, we're simply going to have the 5th root of t to the 3rd power. On problem number 5, that power only applies to the b, so the 8 is out front, and then we have the 9th root of b to the 4th inside. For problem number 6, that 1/6 power stands for a 1/6 root, and so we will have c squared d inside. And for number 7, I'm going to rewrite this as 1 over 7x to the 1/4 power, which would become 1 over the 4th root of 7x. Now, technically, this is not as simplified as it can be because it has a radical in the denominator, but since it only told us to convert it to be in a simplified radical, I think that's where we're going to leave this directions here. Technically, you know that you need to rationalize the denominator whenever there's a radical in the denominator. So we'll come back to something like that later.